Hi, today we're going to be doing chapter 13-2, Solving Trig Equations. This is on page 3 of your chapter 13 note packet. The trig equations that we're going to be solving are factorable, quadratic. And you remember quadratic means you're going to have an x squared in your equation. That's what a quadratic equation is something with the highest degree exponent of 2. So what we're going to do is solve second degree trig equations, which means quadratic, just like you solve algebra quadratic equations. But remember, in the end, you're going to have to give me what the angles are. And you're not going to stop when you've solved for the trig function, which means like you're going to get to a point where it might say sine of x is equal to 1/2. You can't stop there. You have to tell me what the angles are, whose sine is equal to 1/2. But what this all means is, here's a familiar looking problem. You've seen this before. It's a quadratic equation. And remember, you have to set it equal to 0 first. And so you're going to subtract 1 from each side. X squared minus x minus 2 is equal to 0. And to solve this, because I said these are all going to be factorable ones, you know that you don't have to use a quadratic formula. You can just factor this into x minus 2 times x plus 1. Plus 1 equals 0. And you know that x is equal to 2 and x is equal to -1. So that's old stuff. Now what we're going to do is solve a second degree trig equation. It's very similar to the one above, but what we're going to have to do is find values of theta, not x. So this equation, sine squared theta minus sine theta minus 1 equals 1, is exactly like this algebra equation that we did. In fact, if we want to let x equal the sine of theta, we can just call this x squared minus x minus 1 equals 1 and do that substitution. It makes it sometimes faster and easier if you just make these kinds of substitutions and then solve it for x. So I'm not going to solve this again. We got x equals 2 and x equals -1 when we did it up there. But it's not x. We let x equal sine of theta. So what this is going to say is sine of theta is equal to 2 and sine of theta is equal to -1. Now what we have to do is figure out what theta is, and our answers have got to be in radians because this says 2 pi. If this said 360, it would be degrees, but this says 2 pi, so it's radians. Well, first of all, we're going to have to find a reference angle. And in order to find a reference angle, we can do second sine. So grab your graphing calculator, press the mode button, make sure your mode is in degrees. Mine always goes back to radians mode, so put your calculator in degrees mode. Make sure you're following along with this. And now in order to find the angle, you're going to do second sine of 2. And watch what your calculator does with this. Second sine of 2. It's going to give you an error message. Because I'll just go to that. Because you can't do an inverse, there is no angle whose sine is equal to 2. This number has got to be between -1 and 1. So because this value is not between -1 and +1, this part of the equation, there is no solution. All right, but on the other hand, we had sine of theta equals 1. Well, what a good idea is to make this into a t-table. I call this a t-table because we're going to have angles that come from sine of theta equals 2, but that is just too big, so we'll put a great big X on that side of it. And over here, sine of theta equals -1. Well, if we do second sine of -1, we're not supposed to put a negative value into an inverse sine because that's going to give us a negative number. Our number has to be positive because it's between 0 and 2 pi. And so I don't want a negative answer like our calculator is going to say. So whenever sine is equal to 0 or 1 or negative 1, when sine or cosine is equal to 0, 1, or negative 1, I want you to use the unit circle to find theta. And what that means is when you have a unit circle, and the four major points on the unit circle are 1, 0, 0, 1. This comes right off from your paper plate also. Negative 1, 0, and 0, negative 1. Remember, these values are the cosine of theta, comma, the sine of theta. And what we're looking for is when the sine of theta is equal to negative 1, we're looking for the y value equaling negative 1, which is down here. Right here on this value, sine is negative 1. And what angle is that when you draw it out? This angle is 270 degrees. But we want radians. So instead of 270, we're going to turn 270 into radians. So it's 270 divided by 360. Divided by 180. Math, frac. So we have 3 over 2, but we're going to put a pi on that numerator. So we have 3 pi over 2, and that will be the only answer to this problem. Sometimes these problems have 4 answers. You have 2 from one side and 2 from the other. Sometimes they have only 2 answers. Sometimes there's 3 answers, and you could get up to 4 answers on these. Let's go through several other problems so you can get used to this. Right here we have cosine squared equals 1, which if we let x equal the cosine of theta, this is just like x squared is equal to 1. Well, we can do this 2 ways. We can take the square root of each side, or we can subtract 1 from each side and set it equal to 0 and factor and say x is equal to negative 1 and x is equal to positive 1. But it's not x, it's cosine. So we're not solving for x, we're solving for the cosine of theta. So I'm going to take this up here, and instead of x, I'm going to say cosine of theta is equal to negative 1. That's on the left side, and over here I'm going to say cosine of theta is equal to positive 1. So there's my t-table. And now I'm going to look up at this unit circle again, and where is the x value equal negative 1? Well, there's only one point, and that's right here on 180 degrees. So theta is equal to 180 degrees, but we want our answer in radians. So our final answer is pi here. Theta is equal to pi. So there's one answer. Now where's the cosine equaling 1? Well, right here, here is where the x value equals 1. So theta is equal to 0 degrees, which is 0 radians. So there are our 2 answers, and they don't want us to include 360 in this, or 2 pi. If you see that, it's less than 2 pi. So don't include that other answer. So there are 2 answers to this problem. The next one, if we let x equal the tangent of theta, this is like x squared is equal to negative x. And don't divide both sides by x, or else you're going to lose a solution. So what you're going to have to do with this one is add x to both sides. X squared plus x, make it equal to 0. Now if you want to factor this, it's got a GCF of x. So x times x plus 1 is equal to 0. That's the factored. And over on this side, if you have an x as a factor, x is equal to 0. And on the inside, x is equal to negative 1. So you have 2 parts of this. So what we're going to do is, this is not x, this is actually tangent of theta. So we're going to set up our t-table that says tangent of theta is equal to 0. Also, the tangent of theta is equal to negative 1. Well, where's the tangent of theta equal to 0? Well, tangent of theta is equal to 0 wherever the sine is equal to 0. And if you go up to this unit circle, where's the sign equal to 0 or where is the y equals 0? It's equal to 0 at 0 degrees and 180 degrees. So theta is equal to 0 and 180 degrees, but they want our answers in radians. So 0 degrees is 0 radians, and 180 degrees is pi radians. So there are two answers here. Now, when the tangent is equal to -1, you have to get a reference angle. So let's right now put the reference angle in. Reference angle comes from second tan of +1. Don't put a negative into an inverse tangent when you're trying to get a reference angle. So the reference angle is 45 degrees. Write that down, please. Reference angle is 45. That's not the answer. Because when you do all students take chemistry, where is tangent a negative value? Tangent is negative in quadrant 2 and 4. So we have a quadrant 2 theta value. We have a quadrant 4 theta value. With a reference angle of 45, if it's from quadrant 2, you do 180 minus 45, which is 135. And we want that converted to radians. So 135 divided by 180, math frac, will give us 3/4. So we have 3 pi over 4 as one of our answers. And in quadrant 4, you do 360 minus the reference angle, which gives you 315. And if you do 315 divided by 180, math frac, you get 7/4, so it's 7 pi over 4. So we have 4 answers to this problem. We have 0 pi, 3 pi over 4, and 7 pi over 4. So yes, sometimes you have just 2 answers. Sometimes you just have 1 answer. Sometimes you have 4 answers. It just depends on the problem. So what it would be really great if you could shut the video off right now and on your own solve these 4 problems. And I know how tempting it is to say, oh, I'm not going to shut it off. I'll just watch you, Mrs. Garner, do the whole thing. Well, honestly, do yourself a favor and shut the video off right now and try it yourself. And I won't talk through it. I'll just write down the solutions. Oops. Over here, because tangent is negative, all students take chemistry says our answers are coming from quadrants 2 and 4. But over here, because tangent is a positive number, the answers are coming from quadrants 1 and 3. Now both of these have a reference angle of 45 degrees because when you do second tangent of 1, just like on the other problem, you get 45. So quadrant 2 is, just like before, 135 degrees, which is 3 pi over 4. And quadrant 4 is 315 degrees, which is 7 pi over 4. It's just like the previous problem. Over here in quadrant 1, the theta value is the same value as the reference angle, and 45 degrees is pi over 4. In quadrant 3, theta is 225 degrees. It's 180 plus 45, and that turns into 5 pi over 4. So we have 4 answers to this problem. 4 answers. Over here, we'll let x equal cosine of theta. So we have 2x squared is equal to x. Do not divide both sides by x. Subtract. Minus x equals 0, and factor this out. So over here, x is 0, and over here, x is 1/2. So it's not x, it's cosine. Equals 0, and the cosine of theta is equal to 1/2. Well, there's no reference angle. Remember, if it's a 0 or a 1 or -1, you have to go back to this unit circle. And where is the x value equal to 0? It's equal to 0 right here up at 90 degrees and down here at 270 degrees. So theta is 90 degrees from the unit circle. There's no reference angle. You might want to write that down. No reference angle for this one. And 90 degrees is pi over 2 radians. And theta also equals 270 degrees, which is equal to 3 pi over 2. So there are 2 of the 4 answers. Over here, this does have a reference angle, so you can do second cos of 1/2. Remember to get the reference angle. And the reference angle is 60 degrees. You want to write that down. So because cosine is positive, we have answers from quadrant 1 and 4. So the theta value is the same thing as the reference angle, and 60 degrees is pi over 3. In quadrant 4, you do 360 minus 60, which is 300, and that turns into 5 pi over 3. So we have 4 answers in this problem. Let's let x equal cosine of theta. So we have 2x squared plus x. Oh, you got to subtract 3 from each side. Minus 1 equals 0. Well, this is a factor in, factor out. 2 times -1 is -2. The factors of -2 that add up to 1 are +2 and -1. So to factor this, you get 2x plus 2, 2x minus 1. Remember that 2x goes in both parts of these parentheses, but then you have to do the factor out, which is a divide by 2. So this turns into x plus 1 times 2x minus 1. So that makes x equal -1, and this makes x equal 1/2. But it's not x, it's cosine of theta equals -1 in our t table, and cosine of theta equals 1/2. Now here it is. Again, we have anytime you have a 0, 1, or -1, there is no reference angle if it's sine or cosine. If it's tangent, that's not true. Like up here, tangent can be equal to 1 and -1, and you do have reference angles. But if it's sine or cosine, you got to go back to this. And where's the cosine equaling -1? Well, the cosine is the x value, and x equals -1 over here at 180 degrees. So theta is 180 degrees, which is pi radians. So there's only one answer over on the left-hand side. Now you do the reference angle again, just like you did before. This reference angle is equal to 60 degrees. And again, because cosine is positive 1/2, you get quadrant 1, quadrant 4, and I'm not going to repeat all this work. I'm just going to put pi over 3 and 5 pi over 3 as there are 3 answers to this one, not 4. Sometimes you got 4, sometimes you got 3. And then cosecant. Well, let's let x equal cosecant of theta. Don't change anything until the very end. So this looks like it's x squared minus x. Oh, subtract 5 from each side, and you get -2 equals 0. So it looks like it's x minus 2 times x plus 1 equals 0. So this is x equals 2, and this is x equals -1. But it's not x, it's cosecant. So cosecant of theta equals 2, and cosecant of theta equals -1, right? Kind of like in our t-table. But what we have to do is we have to flip this upside down. So we flip the cosecant upside down and we get sine. So the 2 gets flipped upside down. So we've got sine of theta equals 1 over 2. And we've got sine of theta equals -1. The reciprocal of -1 is -1. So sine of theta is equal to -1. Well, here's a sine equaling -1. Again, there's no reference angle for this one. But there is a reference angle for this one. If you do second sine of 1/2, you get 30 degrees. So the reference angle is equal to 30 degrees. Sine is positive in quadrants 1 and 2. So theta is 30 degrees, and in radians, that's pi over 6. So there's one answer. In quadrant 2, theta is 180 minus 30, which is 150, and if you change that into radians, it turns out to be 5 pi over 6. So there are two answers. And where is sine equaling -1? Well, you go and find where the y is -1, and you come around here, and here's where y is -1, down here at 270. So no reference angle, it's just 270 degrees, which in radians is 3 pi over 2. So in this problem we have 1, 2, 3 answers. Sometimes 4, sometimes 3, sometimes 2, sometimes 1. Have a great night.